Hi, my name's Rufus and this is rigging tutorial number 3. I am going to do a spider rig very soon, but in the meantime this captured my imagination the other evening when I was thinking about practical applications for other math formula, which was a result of doing the pole vector tutorial the other day. So I was thinking about how to plot a curve like this one here, and thinking that that could be kind of half of a sine wave, and the sine wave is a continuous wave that's created by this formula down here, and this formula is, take you through it quickly, A for amplitude, which is this here, which is times sine of 2 pi over lambda, or the Half-Life logo. And lambda here is the period at which point the wave goes back to its the point at which it resets itself. So I was thinking that this might be a kind of a cool thing to play with, considering noodle joints. And when you look at a kind of a arm, let's say an arm joint in Maya, you might have, so you've got 3 joints, which are the shoulder, the elbow and the wrist, and then you'd want to kind of place joints along each limb that are intermittently spaced apart. Well, then you've got to kind of figure out what the distance is, and in order to do that you might create a node, a multiply divide node to figure out the space in between, or you might use arc length or something, and then on top of that you've got the sort of controllers to control the twist joints that go over the top of that. So this kind of, a very sort of practical solution, and it's probably more what you'd expect, but then I kind of thought about exploring the maths a little bit, so that's what I'm going to do now. Cool. Okay, so I've opened Maya and I've docked the script editor next to the viewport so we can write some script and you can see what's going on in the viewport at the same time. I've also made a test scene which isn't anything more than an arm in a layer, so that's it. So in order to start scripting, just need to create an arm joint like that, which is going to be a shoulder, an elbow and a wrist. And I'm just going to orient these joints to make sure that they're oriented to the way that I want them to be, just so I don't get any unexpected results. So I want X to follow down the joint chain, and I also want Y to be up, so I know that if I move things in the Y, it's going to move in that direction. So that's shifted, and then last one I'm going to go orient joint to world. So there we are, Y is up, X is following through the joint chain, and Z is forward. Cool, and you can just sort of pick-walk through the joint chain with the cursor keys. So first of all I'm going to create a procedure, proc, and I'm going to give it a name. We'll create noodle joints, and open and close parentheses, and then some curly brackets. And the first thing that I'm going to do is assign a selection to a string, or a string array. So I'm going to call the string selected, I'm going to make it an array, and then inside the back quotes I'm going to use the list command and then selected like that, which means that anything that we've got selected is going to be stored in this string array here. So next up I'm going to assign some names to a string array as well. So I'm going to create control names, and that's going to be string control name, and that's going to be inside an array. And string arrays exist inside curly brackets like that, and the two names that we're going to use are Noodle control 01 and Noodle control 02, like that. And we're going to use this later as shorthand rather than keep typing out Noodle control 01 and Noodle control 02. So next up, we're going to need to find some positions in the scene of these joints here, and that'll help us plot our noodle joints. So we're going to find translations, and the way I'm going to do it is by creating a float, and I'm going to call it matrix joint x, and that's going to be get at and then inside that's going to be selection 0 plus the dot world matrix, like that, and then put a semicolon at the end to close that one. And I also need another back quote there, otherwise it's going to throw up an error. And I'm going to copy and paste this line, and I'm just going to change the variable to make sure it's matrix joint y, and then that's going to be selection 1 in our selected joints. So if I've got the shoulder here and the elbow here, the shoulder's going to be 0 and the elbow's going to be 1. Cool. And next up, I'm going to assign the values in our float matrix to a vector. So I'm going to create a vector, if I can spell it properly, and I'm going to call that vec_x, and that's going to be written out in this format, where I take matrix joint and assign three of the floats in the float array to the vector. So a vector is like x, y, z. So that's going to be 12, 13 and 14, which will give us our translation x, y, z for our shoulder joint. And then I'm going to copy and paste this and do the same for the elbow joint as well. So vec y is going to be matrix joint y, x, y and z. Okay, that's cool. And then next up, I'm going to make sure that we have a vector that is relative to our joint chain, because if you look at the arm, it starts at an arbitrary point in world space and not at 0. So we need to consider that gap there when we're doing our maths. So I'm going to create a vector relative to beginning of joint chain. And I recommend commenting on each line, not on each line, but each block of code, just to give clear indication of what you're doing, and it helps keep track of the kind of mental process as well. So we're going to create another vector, and this one's going to be vector z, and it's really simple. It's going to be vec y minus vec x, like that, and that's semicolon. And then last of all, just do a quick print command just to make sure that we don't have any errors at this point. So print, and just grab this and copy and paste it there. So let's see how we're doing. Okay, cool. So everything's the syntax isn't throwing up any errors, which is good, and we're also getting a result on vec z. So if we go 5 along in x and minus 0.5 in z, so okay, so that's given us our relative distance between these two joints here, away from the origin. So we've gone 1, 2, 3, 4, 5, and nothing in the y-axis, but minus half a unit in minus z. Okay, so next up, so far so good, I'm going to create an integer, which is a whole number, and this is going to be the value where we determine or give the amount of noodle joints that we want to create. So I'm just going to write a quick comment, create noodle, say create number of noodle joints, and we're gonna in a and gonna say that's 8. And next up, I need to create some controls to help measure the distance. So I'm going to create not only measure distance, but to give some controllability about how the joints move around. And you can do more elaborate things, but for the case of getting this sort of done, it's just a kind of work in progress idea. I'm going to use I'm going to use locator. I'm going to give it a name, and I'm going to call it the name of the control, which is up here, and so that's going to be control name 0, like that. And then I'm going to give it put it in a group, so it's got a translation rotation scale buffer. So I'm going to create a group and give that a name, and that's going to be not 90, that's going to be control name 0, and that's plus this string buffer, like that. And last of all, we want to make sure that its groups are control, so I'm going to append that onto the end, like that. And then next up, I'm going to move it to where I want it to go, so I'm going to use xform, and it's going to be in world space, and we want translation, and I'm going to use so vector x is our shoulder joint, so I'm going to make sure that it goes to this set of coordinates, or this vector here. So that's going to be x, and then y, and then z. Tell you what, it's not a good idea to drink coffee just before doing this tutorial. It's probably best done when my head isn't so swimmy. But anyway, let's crack on. So that's control name 0 plus buffer, and I could have just copied and pasted this. Let's type that out for the time being. And then last of all, I'm going to make sure that we move that our control is the parent of the joint chain. So I'm going to say parent, and I'm going to take this name here. This is our buffer, and then I'm going to assign it to our initial joint in our array, which is going to be selection 0. That's cool. So that's going to be create shoulder control, and next up I'm going to make one more control for the elbow. So I'm just going to copy and paste that, and I'm going to go through, change this to elbow, and that's going to be control name 1, and then its buffer is going to be control name 1 buffer, and it's going to group the next one along in the string array. So everything that was the shoulder is now going to be the elbow. So I've just changed all those to ones, which means that it's no longer going to call this string in. It's going to use 0, 1 in our string, which is control 2. So control 1 is going here and control 2 is going there. Cool. So next up, I'm going to create a for loop, which is going to iterate through a loop and help create our joints. And if you're not too clued up on for loops, they're worth checking out. They're very handy, and they can cut out a lot of time and hassle by doing a simple process of just sort of repeating through the same thing. So in order to compose this for loop, I'm going to go I equals 0, and then I equals, no, I is less than or equal to, that's going to be the amount of integer a, which is going to be the amount of joints we created. So this for loop is going to iterate through 8 times if that's the amount of joints that we decide to make. If I change this to 5, it's going to a is going to be a value of 5. So that's a for loop there, and then I'm going to open curly brackets, and the first thing we're going to do is create a vector to place Noodle joints. So for joints, the joint command isn't that intuitive in Mel. So in order to place joints, I've got to make sure that I'm not going to have anything selected. Otherwise, I think it automatically assumes that you're creating the next joint along in a chain. And considering that we've assigned a string up here to whatever we've got selected, which in this case is going to be the first 2 joints in the chain, I need to declare down here that we're going to clear the selection like that. And next up, I'm going to create another vector, and I'm going to call this joint pos, and that is going to be a bit of math. So we're going to say that's vec z, which is divided by the amount of joints that we've got, the amount of twist joints that we're going to have, and that is going to be times I, and then plus, excuse me, vector x. So we go along. So we're going to, so this is going to loop through 8 times, and each time it's going to create a vector called joint pos, and that is going to be vector z, which is this distance here, which is divided by 8 times the amount of times it's looped through. So so it's going to be 0, 1, 2, 3, 4, 5, and then plus vector z, vector x, which is our offset here. So it's going to start here, and it's going to loop through and create 8 points along here. So next up, I'm going to use the joint command and joint position, and that's going to be our vector here. And once again, we're going to declare the position x, y, and z. So point x, then y and z, x, y, and z. And then we're going to give each joint a name, and call these Noodle joint 0 plus, and I'm going to put $I on because this is going to be a sort of a number, an increasing number, so it's going to be joint 0, 0, joint 0, 1, joint 0, 2, joint 0, 0, 3, and then last of all I'm going to give them a radius of 0.1, just because we can see them, we can differentiate them in the viewport to our main joints here. Okay, so next up, what am I going to do next up? And why have I got a curly bracket there? Okay, so this must be inside our for loop, like that. So next up, I'm going to parent our noodle joint to the joint that we've to our shoulder joint. So I'm going to write parent, and then take this. Oh my gosh, this is the effects of coffee. Your fingers get a little too jittery. So that's going to be parent to our selection 0, like that. So everything gets parented to our shoulder joint, and then yeah, let's run this and make sure there aren't any sort of errors or anything. So it looks like there are some errors, so I'm just going to sort of check through them quickly. So first off, this one looks quite obvious. I've put in an extra $sign there. And what else? There seems to be an error here as well. So vector joint pos equals so that opens and closes that. So there may be one too many here. Okay, so that seems to have run okay. So with our 2 joints selected here, I'm going to run this, and you can see now it's created our controls here and our joints along here. However, I don't have a second control on the elbow here, so I'm going to press Ctrl Z and figure out what I did wrong when I copied and pasted the script. So that's going to be so I'm going to make that the parent of the shoulder as well, so that's going to be relative to the shoulder and not the parent of the elbow anymore. And I can see what I've done wrong. I placed it at Vec X, which is our shoulder, and I should have placed it on our elbow like that. So that's the dangers of copying and pasting. So if I run this again and then get our 2 joints selected, we can see now that here's our elbow control and there's our shoulder control, and along the shoulder are our joints, which are equally spaced out. So yeah, so far so good. So next up, we need to figure out how to compose this formula into MelScript, and I think in the simplest way, it's a complete nightmare. It's a ball ache. Okay, so one way that we can get that formula to plug into our Maya objects is with an expression, and unfortunately expressions aren't the easiest things to write in MelScript because the expected syntax is in a string format. So if it's not written perfectly, it can throw up some errors, and then it can be quite difficult to figure out what's wrong. But we'll carry on and just see how it goes. So first of all, I'm going to write a comment, and I'm going to create expression for Sinewave, and then I'm going to type expression. It's going to go onto the object. It's going to go onto our Noodle joint, so like that, and then I'm going to start writing the string with that flag there. I'm just going to expand the window out, and I'm going to write Noodle joint 0, which is going to be plus $I plus dot translate y. So our translate y is y. I oriented the joints earlier to make sure that y was upwards, so we can see the result in that axis, hopefully. And then that is going to be equal to, well, we need a magnitude, and what's going to supply the magnitude? Well, hopefully it's going to be the controller here. So I'm going to say, oh, hang on, so that shouldn't be there, and I'll explain why soon. So our Noodle control 1 dot translate y, so that's going to be our sorry, I said magnitude, I meant amplitude, but yeah, that's going to be the control for our noodle joints, and this is going to be times sine, which is going to be 2 pi. So I need to move this along so you can kind of see. So that's going to be 2 times pi, and the numerical form of pi is 3.14159, and that's going to be times the noodle joint translate x. So we're going to take that bit, and then I'm going to copy it in that bit there, but I'm going to make sure that's not there as well. And this is the syntax I was talking about. It's keeping on top of how this string is constructed in the script editor, and it can be quite a ball ache. So that's going to be translate x, not translate y, capital X, and going to close off those brackets, and that's going to be divided by lambda, or the Black Mesa Half-Life logo, or the period of the sine wave, which is going to be a string plus our control name, which is going to be control name 1. So that's the elbow joint there. The elbow joint is going to dictate the distance of our range. So just got to make sure that I type this all properly, and I don't know if I can't seem to make this any wider. It's sort of almost full screen now. So that's going to be plus, and we're going to take the measurement from the buffer, so that will have the that should have the translations stored there. So I go get the translate x of the buffer and close that part of the statement. So that's our string, which should be a mel equivalent of the formula that we saw to get a sine wave. And last of all, I'm going to give the expression a name, and I'm going to call it noodle joint 0, and it's going to be plus I. So all of our expression names have different numbers, and just going to call it expression like that, and then close that up, and that should be our name of the expression there. Okay, so next up, I'm going to run this, and I'm fully expecting some errors to flag up, but before I do that, I'm going to make sure that we're just back to our 3 joints here, and we've got our first joint and our second joint selected. So I'm going to select the script and execute it, and then, as you can imagine, we've got lots of errors. So it looks like I've misspelt sine. So I was talking about sine waves, and I should have actually used sin like that. So if I undo that last procedure and then execute it, Now, you should see now that our controller now controls our joints in the way you'd expect a sine wave to. And if you can imagine, this could be our noodle joint like this. However, we could take this one step further. So if you can imagine that our noodle joint doesn't actually really want to be a sine wave, but more of a kind of curve on the arm, then you could just change the period or the range of the sine wave, so we get more of a curve like this. So in order to do that, what I'm going to do is change the expression slightly. I'm going to undo our script, and we're going to say that that's, if I expand this out so we can see the whole string again, I'm going to say that that's going to, we want 2 times the length of our period, but also we're going to make it work in another axis as well. So sine wave x, and copy and paste that, and then we're going to make this work for the z-axis too. So let's say that the translate z is controlled by our control z, and sine stays the same, pi stays the same, and our that stays the same, and our period stays the same, and then I'm just going to give them different names. So that's going to be y expression, and this one is going to be z expression. So now we've got 2 different names. So hopefully that should now, if I run that and then run the procedure, you should see now that we now have a pretty sweet sort of mathematically calculated curve that works in kind of all directions like that. So yeah, that caught my mind the other day, and I thought it was worth exploring. So I think that's a pretty cool result for, like, you know, 20 minutes of scripting. And I think the next thing to do is just sort of skin the arm and figure out, you know, and see the results. So I'm going to pause the video and do a quick skinning pass and yeah, show it to you. Cool, cheers. Hey, so I've just done a skinning pass on our arm, and I'll just turn on wireframe, and here are the results. So I think that works out pretty well. As I said at the beginning, this isn't a complete tutorial, but in order to kind of explore an idea, sometimes it's good to have a kind of, you know, a kind of investigative approach to these things. So yeah, that's a lot of deformation driven by a few expressions and basically 1 or 2 controls. So I think that's, you know, it's quite a nice result considering. Alright, cheers, brilliant.